3. Let's see if we are online. Um, I cannot see it coming yet. Um,
Let me also check in the.
yeah, could you please check if we are online? Because
Mhm.
here in
Yes, just a second. I think there's some echo, but
yeah,
we are online.
okay, great. So
Okay, so good morning, Alan. Good morning, everyone. Good evening or good night, whatever we see that.
yeah, good morning, Rodrigo. How are you doing? How are things?
Uh, yeah, I'm
Everything
fine. I'm
fine?
fine. How
Great.
about you?
Fine, everything all right. And so, uh, tell us what what were the plan for today? What the idea? And if you can share more
Yes.
details.
So today we are going to add support to our board to a LED, addressable LED. Let me show you
Mm-hmm.
what is the model we are talking about. So is that one, and we have here 10 addressable LEDs, and uh,
Mm-hmm.
we're going to add support to this one.
10,
This guy
10
here,
LEDs
they have
to
LEDs, yes.
to control from.
Yeah. So this model has a Grove connector here.
Mm-hmm.
So I will show you guys how I'm connecting that, but uh, let me share my camera here. And so yeah, so this guy here, you can see here the I think I can put here
Yeah,
the
the cables.
connector.
Yeah.
Yeah, and so this model we just need to connect the power and the ground,
Mm-hmm.
and it use the SPI and just the MOSI SPI, so just the output from the SPI. It doesn't need the clock or the input, so I'm just use the P7 here. That is the SPI1 MOSI for our board, right?
Mm-hmm.
And yeah, that's it. Basically, that is the model that we're going to play today.
Oh, nice. Yeah, these RGB LEDs are very common and very useful for some light effects and also many projects that involve uh, controlling the LEDs bright and the if you want to like create some rainbow or some some very beautiful effects, these
Mhm.
LEDs are really cool for that. Yeah.
Nice. So I think the example, as we just talked, is we are this example. They will turn on all the LEDs,
Mm-hmm.
all the LEDs in one color, and it will be transitioned to other colors to
Yeah.
make this effect.
Yeah.
And just one last comment regarding the model. They, uh, as you can see here, oops, sorry,
Mm-hmm.
it used the WS2813, but the drive you have is for the WS3812,
Mm-hmm.
but it's fully compatible, so we can use the same.
Yeah.
I think the difference is minor,
Mm-hmm.
and so you can use the same driver.
Oh, nice. Yeah, I don't know the difference. Maybe you also don't remember the difference. So maybe if someone want to put some comment here in the live, what are the difference? I think it's good for let people to share ideas and see what are the difference. But as you said, they are compatible. This is the most important thing. So uh, and you confirm it is working, right?
Yeah. Yeah.
Okay,
Okay, so let's go for it. I will
right.
remove this one here.
Do you want to show it working before starting. Maybe it's nice so that people can see it working, and then you show
Yes,
how you
yes.
did it.
So I already tested that. So I will get here in the okay.
Mm-hmm.
So there is a example application
Mm-hmm.
that is this WS2812 and okay, sorry.
Yeah,
Let
we
me
need to put in
put this
in
one a little bigger
and
and maybe put
on top.
our up so you guys can see even when I type here. So if you run the application, in fact, the camera made
Yeah, but it's cool. We can see it from here. Yeah,
okay.
it's transitioning from um, green to yellow to blue to yellow, red, purple. Yeah,
Mhm.
really cool.
Nice.
Yeah.
So that's yeah, that's the example application. So, but we're going to start from scratch. So
Mm-hmm.
just to show you guys how this works.
Yeah. Okay. Perfect.
Okay, so let's take this away for a while, and I think I can keep this here, no problem. And so here I have a clean workspace. I have just get the latest from upstream this morning, so we are with the uh, uh, latest code for that. And uh, I already did the disk clean. I just you configure. Oops. And I will use the USB NSH, right? That's the one that you
Yeah.
I will configure for this one. Okay, let me put some code here. So yeah, you guys can see the Visual Studio Code, right?
Yeah.
Okay. So this for STM32, we have this driver, this model already added in the common. So if you go here in common, in source, uh, you can see it's already here, right?
Mm-hmm.
So if anyone want to use this same example or want to use this in a different board that is not under STM32, you may also need to copy this one and change according to our platform. But for us, as this is already in the common, we are just going to initialize that in the bring up, okay? And for that, I will use the example that's already here in this STM32F1, the blue pill, right?
Mm-hmm.
So we have here in the bring up, I need to include the .8. Okay, so I'll do that to our board. Okay, let's go to, okay, I have a lot of configs already here. Let's go to our board. And in your bring up, we need to add this. Okay. Uh, also, oops, sorry. Also, we need to initialize that in the bring up routine. So I will copy this here and also add in your bring up here on the end. You guys, you see that you have just there's just a little of code to add that in this board because it's already in common.
Mm-hmm.
So just need to initialize that here. I put here in the end of this file. Okay, and we need also to define as I said, this module uses SPI, so we need to define which SPI. and also the number of LEDs that we have.
Mm-hmm.
So in the case of the example in the minimum, in the blue pill was 2, but in your case it will be 10. So let's do that. Okay, going here to my .8, and I think I'll put here SPI. I'll put it here. Yeah, I think it should be okay if I put it here. So here we have 10 LEDs. Okay. Let me make sure I'll also save everything here. And I think that's all for the code. I just need to now to enable that in the menu config, right? So let's go back to the and here I'm going to make
About the yeah, I was thinking about the Makefile mice, but you don't need to. Sorry, I have a
yeah
my throat.
because it's
You,
already in the
yeah,
common,
in the
right?
common, so you don't need to modify
Uh,
anything. Yeah, you're right.
so as I said, that won't be fast because
Mm-hmm.
I reused most of the work you did already. So just some small things that I need to do. So here, what we need to do? We need to enable the common board support because, as you just said, we are using the common. We need to enable the SPI one. We need to enable the LED driver, and we
Mm-hmm.
need to enable the application. That's the 4 things we need to do. So let's do that. So in system type, STM peripheral support. We just enable the SPI one. Okay. And board selection, we just enable the common board logic. Okay.
Mm-hmm.
And device drives, I think you have the LED support. And here we need to enable the WS2812 LED driver. We need to change here the number of connected LEDs to 10.
Mm.
So you
Oh,
guys can use.
it is strange because in the minimum you already defined it, so maybe that define should use this one instead of code it hard code in the source code, right?
Uh, Yeah, you can do some tests. You can do some tests because
Yeah. Maybe we can change the source code later to use these numbers from here because it's more
mhm.
flexible, right?
Yeah, to be honest, that I did this a couple of weeks ago, so I don't remember exactly, but
Mm-hmm.
I think if you didn't, if you we need to change both sides, the source code and also here.
Yeah.
Otherwise, they use only if I let's keep 2 here and 10 there,
Yeah.
only 2 LEDs will be turn on, turn off. So
Yeah.
we need to match these numbers. But yeah, we can instead of get from here, get from the source code, you mean, right?
Yeah. Just before move on, go
Uh-huh.
to support new non SPI. I think this one is for example, for ESP32 that use not SPI but uh, RMT, for example.
Hmm.
Yeah, yeah, exactly. I think others.
Yeah. But
Yeah, it's a different. This is not only
uh,
for ESP32, but here, for example, for RP2040 for the
mhm,
Raspberry Pi Pico.
yeah,
Yeah, okay. I was just my curiosity.
no problem. So okay, so let's keep that. Can we keep that 10 and
Mm-hmm.
later we can try to change that?
Yeah.
Okay. So let support is already enabled. We did already three things. I think there is the last one that is enable the application.
Mm-hmm.
So we have here some examples. Let's find the example. Should be near to the end. Okay, this one here.
Mm-hmm.
Okay, so the program is, yeah,
Yeah,
I think that,
I think
yeah.
you need to change these LEDs uh, device file as well, right? Because in the bring up, I think the name of slash dev was different.
Mm,
Just double check that.
yeah, let me. Okay, that's nice catch. So,
Mm. Yeah, you need to go to boards for the common board
okay,
tab S
we need,
2812
oops, sorry, I
common.
pressed so common, source, I need to check here, right?
Yeah, yeah. See,
Uh,
LED driver 0.
yeah, let the, let me change that, but before just let me get my notes here.
Mm-hmm.
Yeah, that's right. You're right. Uh, okay, so here I need to edit this, and is the LED drive
0.
0. Okay, thanks.
Welcome.
Okay, so that's all. I
Mm-hmm.
think that's all right.
Yeah.
So let's save that and make. Let's bring this here.
Oh,
Oops.
what's the why is not supporting this frequency? Maybe you need to change the SPI frequency as well.
Hmm.
It cannot be 18 megahertz.
Okay. WSS error supported frequency. So maybe you can check the driver, right? Why not? Just to,
Yeah, could be maybe the frequency is there. Don't you remember the frequency that you use?
so resistor, fail to locate instance, fail to locate the X buffer. What's the error message? Line 84, 85. So it's okay. So let's check that. Okay. With frequency. Okay.
Yeah,
I
but
think I use this. Okay.
yeah, it
I
should
think I
be
use this.
yeah, it should be more than 36 megahertz. Oh, sorry, not 36, right? 3.6. Between 3.6 and 5 megahertz or above uh, hmm,
equal or above the 9.
9 megahertz.
Yeah.
Should be
So
l- less than 9 megahertz and more than 5.9 megahertz.
okay, I think I use 9, exactly 9
Okay, cool.
when I did my example. So let's go there. So that is in the driver, right? So driver.
Driver LED. Yeah,
Uh, yeah. So here I use 9, but I think I'm missing a 0 here.
yeah, one more zero.
Yeah. Okay. That's what I used when I tested that. So let's keep. Okay. Okay. So now I'll bring back this one here, and I'll put the device in flash mode. I use DFU to flash it. I reset the board. Okay. Get back to the oops here. Sorry.
Yeah, maybe you create like TTY ACM1 because you are with this one open. So try to
Mm,
leave the minicon, remove the cable and connect again. Maybe it will fix.
mhm.
Sometimes the
Okay, so
Linux
let's
cannot.
go to
Yeah,
Ctrl X. Why they are not is Ctrl A then X. Okay, yeah. Leave minicon.
yeah. Remove
I'll
the cable.
remove the cable.
Yeah, you can also type sudo demask to see if was created correctly.
The mask.
No,
Okay.
you
What?
put on.
Sorry. Okay. Yeah.
Yeah, now it's okay.
So now it's in ACM1.
No, the last line.
Okay, this one. Yeah, perfect. So let's do that. Okay. So on the so just compile that, right?
Hmm.
I think if you and if you come here, you have the application. Let's see if you have. So you have here the LED driver, and let's run the application. Oh, sorry, I moved that away from that from here. But now, yeah,
Yeah, cool. Very nice.
yeah, that's working.
Yeah, it's very simple to do, and only some details you need to pay attention, right?
Yeah.
But very simple to get it work on NuttX.
Do you want to play with the number of LEDs or maybe another?
No, my suggestion was just to fix the source code because if there's some definition as we saw in the
Mhm.
menu config, we don't need to have the number of LEDs defined again in the source code. the
hard coded, right?
hard
Yeah.
coded there exactly. It should use the config number of LEDs, for example. But
Hmm.
you can do it later and submit PR to the main line.
Okay, perfect.
Yeah. Okay. I think we are done, right? It was very fast today.
Yeah,
Less than half hour. Yeah.
that's nice.
Yeah.
So there is that's nice because sometimes videos if 1 hour or more is difficult to watch the
Yeah.
entire
No.
video. So
Exactly. Not
yeah,
everybody want to spend too much time to see all the details, and
yeah.
this one is very fast and very good. Yeah. Cool.
Okay, so thanks a lot, Alan.
Thank you,
Thank you
Rodrigo,
guys to watching.
for doing that.
No problem.
Okay.
See you in the next live.
See you. Bye bye.
Bye bye.